Hi, this is Alex from devstories.eu. Python, Cheminformatics, and AI, Episode 2 of 22. A single missing coordinate in a million-molecule dataset can crash your entire pipeline. If you assume every text record in your vendor file is perfectly formatted chemistry, your Python script will eventually throw a fatal exception halfway through a 10-hour job. Defending against dirty data while moving structures in and out of your scripts is mandatory, and that is exactly what we resolve today with I/O and Cheminformatics. When you receive a standard structure data file, or SDF, full of potential ligands, you need a way to parse it. In RDKit, the default tool for this is the SD molecule supplier. You initialize it by passing the file path as a string. This supplier object acts very much like a Python list. You can loop over it, you can ask for its total length, and you can pull out a specific record by its index number. It does this by scanning the file quickly to find where each molecule starts, allowing you to jump around the data. Sometimes you cannot scan ahead. If you are piping data directly from a web stream or reading a massive gzipped file chunk by chunk, you do not have random access. For these situations, you use the forward SD molecule supplier. Instead of a file path, you pass it an open file object. This forward supplier is a strict iterator. It reads one molecule, parses it, and immediately moves to the next. You cannot ask for its length, and you cannot ask for the 50th molecule without reading the first 49. You trade flexibility for low memory usage and stream compatibility. Here is the key insight. Regardless of which supplier you use, RDKit does not raise a Python exception when it encounters a corrupted molecule. If a text block in your file has an invalid valence or a formatting typo, RDKit will output an error message to the console, but the actual Python object it yields for that loop iteration will simply be the none type. If you take that none object and try to calculate its weight or write it to a new file, your script will crash. Handling this is simple but critical. The very first line inside your parsing loop must always check if the yielded molecule is none. If it is none, you use the continue statement to skip to the next record. This silently filters out the garbage data and keeps your pipeline running. Once you have safely parsed and filtered your valid molecules, you usually need to save the results. For this, you use the SD writer. You initialize the writer by passing your desired output file path. Inside your safe loop, right after your none check, you pass the valid molecule object to the writer using its write method. Once the loop finishes processing every ligand, you call the close method on the writer to ensure all data flushes to the disk safely. You can also wrap the writer in a standard Python context manager so it closes itself automatically when the block ends. To put this all together for a data cleaning script, first, create your SD writer for the output file. Second, create your SD molecule supplier for the input file. Loop through the supplier, check if the current item is none, and if so, skip it. If it is valid, hand it to the writer. Close the writer at the end. Always treat external chemistry datasets as inherently dirty. Verifying that a parsed molecule is not none is the cheapest insurance policy your code will ever have. That's all for this one. Thanks for listening and keep building.